Now we will discuss about addition of vectors. So as you know, scalar quantities, what we mean to add 5 plus 3 kilograms of two masses having mass 5 kilogram and 3 kilogram. Why we add them? Why we need to add them? Two masses, one is 5 kilogram, second is 3 kilogram. Why we add them? We add these two masses to feel the resultant effect of these two masses. We want these are two different masses. One is 5 kilogram, second is 3 kilogram. So we add these two masses to feel the resultant or net effect or combined effect of both these masses. That we mean when we add scalar quantities. So if this was experiencing, let us say, 50 Newton force, gravitational force, this was experiencing 330 Newton, let G is 10 meter per second square, acceleration due to gravity. So total mass is this total mass of 8 kilogram single block will experience a force of 80 Newton. So here we have added both these mass and we find that this mass experiencing 50 Newton gravitational force, this mass experiencing 30 Newton gravitational force. When we put those masses together, and we want to find resultant force, resultant effect of this new mass of 8 kilogram, then we can just simply algebraically add them, and a mass of 8 kilogram, that's the new mass, will have attraction due to gravity 80 Newton. So here we can say that this is the resultant mass of these two masses, because the net attraction due to gravity in this mass is equal to combined attraction, that is 50 plus 30 Newton on these both masses. So we say 8 kilogram mass is the resultant mass of 5 and 3 kilogram. Or another word, we can say, if a force is applied on this full system, if a force is applied F, then the whole system will move with the acceleration F divided by 3 plus 5 is equal to F by 8. Similarly, this 8 kilogram mass will also move with acceleration F by 8. So in all terms, this 8 kilogram mass is equivalent to both these masses. Whether we apply external force, whether we find the total weight of this system is total weight of this system, that is 80 Newton. Net acceleration is F by 8 for this whole system when a force F is applied. Similarly, this 8 kilogram single mass will also experience F by 8 meter per second square acceleration when a force F is applied on this. So in all aspects, we can say this 8 kilogram single mass is resultant of this both masses. That we mean to say what is resultant, what is combined effect. In all physical studies, you know this 8 kilogram mass will behave exactly similar manner as both these mass will behave jointly. Both these mass will behave jointly in the same manner this single 8 kilogram mass will behave. So what we mean, what I want to explain with this example about the resultant. What do you mean by a resultant quantity? Resultant quantity is that quantity which is equivalent to other two or more than two quantities in all physical observations. All type of physical observation, the observation made for resultant quantity will be similar with observations of its components, component quantity. So the resultant means the observation, the joint effect of all more than two or more than two quantity will be similar to single effect observed on resultant quantity. That is the meaning of resultant. So similarly in vector quantities also, what we mean by adding two vectors, by adding two vectors we get a third vector, that is called resultant of those vectors. So resultant of those two vectors means the single physical effect of that resultant vector in all aspects will be similar to joint effect, combined effect, those two vectors which are being added and their addition is the resultant vector. So the effect must be same, physical effect must be same for resultant and its component. So let us take an example of displacement. Let there is a point O. A person moves from O to A. Moves from point O to point A. Then that person moves from point A to point B. So in first case his displacement from O was OA. In second case his displacement from A was AB. So these are, displacement is a vector quantity. So first vector is vector OA, this vector. We have second vector, vector AB, this vector. Now we want to know what is the resultant vector. What do we mean by resultant? Resultant vector should be that displacement which should have equal physical effect of both these two vectors. So we know the final displacement from O to B is this, OB. So because rather than moving from O to A and A to B, if he only moves from O to B, then net effect is same in both these cases. Person goes through this path or he goes through this path. The end effect is same. That is the meaning of resultant. In this case, end effect, finally he reaches B. In this, if he follow this direct path, in that case also he will reach to B. In both cases, the effect is same. So we can say this OB displacement is addition of OA and AB. Because this displacement vector is equivalent and gives same effect, end effect, to when these two vectors are jointly considered. Two displacements are jointly considered. Effect of these two displacement is same with effect of this displacement. So vector OB, displacement OB, we will say is resultant vector of OA and AB, or we will say vector OA is sum of vector OB is sum of vector OA and AB. That we mean when we say about addition of vector. Addition of vector means the effect must be same. So we see here these displacement vectors cannot Displacement cannot be directly added like mass, which we have added like 5 plus 3. It has to be added geometrically. It must follow geometric rules of geometry. So this is the inherent nature of vector quantities. They follow geometric rules. They are not added directly except in case of collinear vectors. You can add them algebraically. Except collinear vectors, all vectors follow geometric rules. They are not directly added. They cannot be added directly. This is the intrinsic nature of vector quantity, inherent nature. They are as it is. They are like this. You cannot question why these vectors are following this geometric rule. Why they are not getting added simply 5 plus 3. They follow geometric rule due to their inherent nature. If person goes from O to A and A to B, then resultant will be AB. It will follow this geometric rule. It cannot be questioned actually. Why it is following this geometric rule? It is the intrinsic property of vector quantities. It is inherent nature of vector quantities. So this is the way vector quantities are added, and we find the resultant of two vector or addition of two vector is defined. Addition means it must have same effect. That's all. So first law which governs the addition of two vectors is parallelogram law. Law of parallelogram. This parallelogram law is very old and it was known since the time of Aristotle. So various Greek mathematicians have used this parallelogram to find the resultant vector quantity. Even though vector word was not available at that time, not used at that time, it was started to be used in 17th and 18th century. Still, how these quantities will be added or the net effect of these quantities will be achieved, it was known since the Greek period. We will discuss here parallelogram law. Parallelogram law says that if two vectors, we are just calling vectors, we are not telling what type of vector, because I have already told you in vector algebra it is sufficient to say vector. It is not necessary to say which vector, force or velocity or whatever. If two vectors are represented by adjacent arms of a parallelogram starting from same point, if these are the two vectors, first vector is represented by this arm, second vector is represented by this arm, so you have to complete a parallelogram based on these two arms. This is vector A, this is vector B. If two vectors are represented by arm of a parallelogram starting from same point, then their resultant vector will be represented by diagonal of this parallelogram starting from same origin point, same point where those vectors were starting. This is will be A plus B. That is the statement of parallelogram law. So you know here you can see these vectors are put along the arm of parallelogram, but you need not to tie those vectors here. This vector can be represented here also. I have already told you. This is vector B, this is vector A. You want to add those vectors, you want to add these two given vectors, you have to join the tail of these two vectors. Tail, right, vector B, this vector is also B, this vector is B, they both are same, parallel and same magnitude. From the same tail, write this vector A parallel to this. So transfer these two vectors in such a way they make a two adjacent sides of a parallelogram starting from same point. And the resultant vector will be represented by diagonal of this parallelogram starting from same point where those two vectors which are being added were starting. So this A, this is point O, this is A, this is B, this is C. So vector OC is vector OA plus vector OB. You can also write A plus B is equal to this vector OC. So this is the way these vectors are added. So there is a formula you can find as you will assume a scale before writing these vectors. So you will write a certain length of OA based on the scale. You will draw a certain length of OB based on that scale. Convert those vector in centimeter, millimeter or meter, whatever it is. And then you will measure by scale the length of this vector. You can directly measure from scale the length of this vector and you will find the resultant vector. This is one way to find the resultant vector. This is a crude method. Just measure all lengths practically from scale and find the resultant vector. You can also measure this angle practically and find the direction of resultant vector. This angle, everything can be measured practically, geometrically. This is one way to find resultant vectors magnitude and direction. Second way, we have also certain formula, geometric formula to find this length without actually measuring their length and angles. So parallelogram law says that resultant vector modulus of OC is equal to under root mod of A square plus mod of B square plus 2 mod of A mod of B cos theta. This whole angle is theta. This is called angle between vector B and A, theta. 2AB cos theta. A square plus B square plus 2AB cos theta under root. This is the magnitude you can calculate of resultant vector. Simply you can write like this. Let this resultant vector is C. C is equal to A plus B. So we can write C is equal to under root A square plus B square plus 2AB cos theta. C is the magnitude of resultant vector. AB is the magnitude of these two vectors. C is A square plus B square plus 2AB cos theta under root. And direction, this angle alpha can be found by tan alpha is equal to A sin theta, A sin theta divided by B plus A cos theta. So this way you can, this is the angle theta of resultant vector from OA. Vector OA and resultant vector are making angle theta. Sorry, alpha with each other. This angle alpha is A is the modulus of this vector A sin theta. A sin theta. This is full angle is theta divided by this vector B plus A cos theta. So how to remember this formula actually? How to remember this formula? So to calculate the tan theta, you just make a right angle triangle. Tan alpha is this length, vertical length by this length. So this vertical length is A sin theta. Like this point is K. So this is the right angle triangle OKC. So tan alpha is CK. Tan alpha is equal to CK divided by OK. CK is this length, tan alpha. This from the definition of trigonometry, definition of sine, cosine also you can find CK is A sine theta. A sine theta. This is A sine theta. And now OK. OK is equal to this length OA plus AK. OA is length of vector B plus AK. AK is horizontal component of this vector. What is the component and all you will learn in future. A cos theta. A cos theta. This length is A cos theta. Length AK. AK is this length and this length are same, A cos theta. So this full length is B plus A cos theta. B plus A cos theta. Because in this direction, if you will vertically divide this vector in vertical and horizontal direction, this will have A sin theta and A cos theta. How to find the component we will learn later, but here I am just explaining you A sin theta, vertical component of a vector, and this component is A cos theta. So A cos theta and this vector O vector B will be equal to full length of this right angle triangle. So this is the way, and to find this angle you can use theta minus alpha. Whole angle is theta, this angle alpha you can find with this formula, and this angle, remaining angle you can find by theta minus alpha. So this way you can find the direction and magnitude without actually measuring by scale. You can find the direction and magnitude of resultant vector by parallelogram law. So parallelogram law gives us angle alpha, direction of resultant vector with respect to given vector, and resultant vector, magnitude of resultant vector. This is how vectors are added using the parallelogram law. Another observation in parallelogram law I will like to mention here. So this is the parallelogram vector A, vector B, and this is the resultant. So the angle of resultant, the resultant vector will incline to vector out of these two adding vector which is greater in magnitude. Suppose vector A and B are same in magnitude, then this angle will be alpha by 2, and this whole angle is theta. When both these vectors have same magnitude, then this resultant vector will make equal angle from A and B, that is alpha by 2 and alpha by 2 is equal to theta by 2. Sorry, alpha and alpha, where alpha is equal to theta by 2. So when the suppose vector A is increasing, this is same. In that case, this diagonal will be inclined toward A. So the inclination of the resultant vector is always towards the vector which is greater in magnitude. Here vector A is more, suppose vector A further increased in magnitude and vector B magnitude is same, so the parallelogram will be extended up to here. The resultant will incline further towards vector A. So this resultant vector, this is one of the observation, resultant vector is inclined to the vector which is greater in size. A and B, these are the two adding vector. Whichever is greater size out of A and B, the resultant vector will be inclined toward the greater size vector. So this is just one of the observations, you can keep in your mind. Now we will discuss second law, that is called triangle law. Here what Newton has mentioned in his book Mathematica Principia, that you can add vectors sequentially, vector quantities. Even he was not aware with vectors because vector name was not used during the age of Newton, but he was dealing with vector quantities like law of motion and the gravitational force, etc. So he used this method of triangular method of addition for vector, which he mentioned as a sequential addition of vector in his book. So what does this law say about addition of vector? This law says that let there is vector A, let there is vector B. These are the two given vectors. We will not mention the nature, it is which kind of vector. That you want to add these vectors. So what law of triangle say, if these two vectors are represented as a dimension of a triangle, regular arms of triangle, vector A, regular arm. So we want to find A plus B. Draw this vector A, draw this vector B, start tail of this vector from its head, and in the same direction this vector B, take the direction of this vector B. So make two arms, regular arms of a triangle with the help of A and B. Then the third arm taken in reverse order. There is order of addition. See, head of this vector, tail of this vector. So this the order is like this, in this direction, A, B, and the order of third vector, it is in this direction. Vector direction is opposite. So take the two vectors in a order as per their direction in the form of sides of a triangle, and take third vector in reverse order. Their order is this order. Third vector order is reverse. Its tail is starting from here and head is here. So its direction is, its order is reverse. So this reverse order, third vector following this reverse order and completing the triangle will be the resultant of A plus B. This is the law of addition of vector, triangle law of triangles. So simple to remember this law, just write a vector, add, start second vector which is being added to this vector from the head of first vector, and end this vector in this same direction, whatever direction is this. And for resultant vector, you just remember, resultant vector head will match with head and tail will match with tail. Please remember this point. Tail of the resultant vector will match the tail of free tail of vectors being added, and head of the resultant vector will match with head, free head of the second vector which is being added. So this is the resultant vector. As per the law of triangles, the vectors are added like this. So this is the A plus B. Let us find B plus A. B plus A. So to find B plus A, you have to draw vector B first. B was this and A was this. Draw this vector first. We will add B plus A here in the same place. Now this A vector. So the second vector's tail will start from head of first vector. This is the vector A. This vector we have shifted at this point, this place. I have already told you vectors are free. They can be transferred from anywhere to anywhere. This A, now this triangle shows addition of A plus B. Vector A is drawn first. From the head of vector, tail of vector B starts, and then resultant vector starting from tail ending from the head is drawn, which is the resultant vector. Now I am finding this operation B plus A. I want to see whether the addition of vector is commutative or not. This is called the law of commutation. B plus A, so I have to draw B vector first. This is the vector B already drawn. From the head of this vector, I will start tail of this A vector. A vector is drawn from this point in this direction with this magnitude. Now what the triangular law says, the resultant vector tail will match with tail, free tail, and head will match with free head. Free head is this. So the head of resultant vector will be this, and tail will match this tail of this. So this is C is equal to B plus A. Now you can see that this and these are parallel, this and these are parallel. So this is a parallelogram. This is a parallelogram. As the parallel sides of parallelogram are same, so I can say that this vector and this vector are same. This vector and this vector is same because these and these vectors are same, and this is a parallelogram. So as per the condition of parallelogram, parallel sides are same in magnitude and direction. So this vector and this vector are same. So we can say that addition of vector follows law of commutation, B plus A. Addition of vector follows law of commutation. And now we will find the direction and magnitude of resultant vector. Suppose this is vector A, this is vector B, and these two vectors actually makes angle theta with each other. So this angle will be theta. This is pi minus theta. This is the resultant vector C. As we have calculated the length and direction of resultant vector in parallelogram law, similarly in triangle law we can also find length and direction of resultant vector. To find the length of this vector, we can use cosine's law for triangle. What that law says, cos pi minus theta is equal to a square plus b square minus c square divided by 2ab, where ABC are the magnitude of these vectors ABC. So this angle is known. So you can write C, which is the magnitude of this vector. C square is equal to a square plus b square minus 2ab cos pi minus theta. So this way you can find magnitude of resultant vector C. Magnitude of resultant vector you can find from this formula. And the direction, this angle let the angle of resultant vector from A vector is alpha. From this cos formula you can say cos alpha is equal to A square plus C square minus B square divided by 2AC. Here you can, from this formula you can find the magnitude of resultant vector. A, B are known, theta is known, cos pi minus theta will be known. So all this, putting this formula, you can find the magnitude of this vector, and this alpha, cos alpha is equal to A square plus C square, and this is vector B minus B square by 2AC. This is a, you might have seen this formula in trigonometry, by 2AC. From this formula you can find the angle theta. So the direction from this reference direction, that is direction of known vector A, this is the known vector, so its direction is known. If you find alpha, so you can find the direction of C from this known direction. So alpha is known, that means direction of this vector, resultant vector is known, and magnitude is also known. So this is the method we can calculate resultant vector by triangle law of triangle. Now we will see how these parallelogram and triangle law are same. Actually they are same, you can easily visualize it. Let there are two vectors B, A. In parallelogram law, we complete a parallelogram based on these given two vectors. This is point A, B, C, D. So parallelogram says that after completing this parallelogram based on these two given vectors, the resultant vector will be denoted by the diagonal of this parallelogram, which starts from same point where vectors A and B are joined. So this is the resultant vector C. And now we will use triangle law. So see the parallelogram, these and these two sides are same, equal in length. So we can say this is also vector A. BC is also vector A because these two sides are parallel and equal in length, because this is a parallelogram. So this side is common and this vector I have transferred here. So this vector is A. So as per triangle law, the resultant vector will start from free tail of vector B and end head of vector B. So this will be A plus B, or will be resultant vector of based on law of triangle. So both are same actually. Parallelogram law and triangle law, both are same. We have proved that vector addition follows commutative law. Addition of vector follows commutative law. There are two other laws which are followed by vector addition, is scalar distributive law, KA plus KB, and associative law. Only addition is these two, commutative law and distribution law are followed by vector addition, and A plus B plus C, let there are three vectors. So before I will mention the polygon law of vector addition to add more than one vectors. So before mentioning that, I am just telling you the vector addition also follows associative law. Whether you can add these two vectors first and the resultant of these two vectors can be added to vector C, or you can add these two vectors first, B and C, and resultant of these two vectors can be added to vector A. These all three equalities of vectors holds true. This is commutative law of vector addition. This is distributive law of vector addition. This is associative law of vector addition. So this associative law I have I will just mention the polygon law, third law of vector addition. When there are more than two vectors, when there are more than two vectors to add, and we want to find resultant of all these vectors, then we can use polygon law. A polygon law. What is polygon? Suppose there are, this is vector A, this is vector B, this is vector C, this is vector D. There are four vectors. So how to add all these four vectors? We can use triangle law. We will first add these two vectors, find the resultant, then add resultant of that these two vectors with this C vector, find the resultant, then resultant of these three vectors will be added to D vector and find the resultant. This is one method by adding by the triangle law. Polygon law says you just make sides of polygon with the help of these vectors in such a way, in a sequential manner. Sequential manner means the head of first vector should match the tail of second vector. When first vector ends, the next vector should start. That is the sequential manner. So we will write vector A. This is vector B. Write vector B in sequential manner here. I have already told you these vectors are free. They can be written anywhere. These were the given vectors. Now we are adding them with the polygon law. I have transferred this vector A here, transferred this vector here to form the polygon. Now this vector can be transferred here. C. This vector is D. So we have made a polygon in a sequential manner by these vectors. Now polygon law says that the resultant of all these vectors will be last vector completing the polygon in such a way its tail should match with free tail of vector and head should match with the free head of last vector. This was the free tail of first vector. This was the free tail of last vector. So just match, complete the polygon, and to decide the direction of resultant vector, match tail of the resultant vector with free tail and head with head of last vector. So this is vector E. This is the resultant vector. So we can say E is equal to A plus B plus C plus D. That is the polygon law of vector addition. So here you will see we have to find this resultant vector by actually measuring this last vector, its angle and its magnitude. Because for polygons of irregular size and shape, there are no standard formulas. There are formula for regular polygon to find the dimension and angle. So unlike parallelogram and triangle law, we may not have formula to calculate resultant vector magnitude and direction. So it has to be found by actual measuring of actual geometric measurement. So this method is seldom used, very infrequently this method is used, but this is one of the law for vector addition. So we have discussed about vector addition with the help of parallelogram law, triangle law and polygon law, and we discussed about some properties of vector addition. They follow commutative property, distributive property and associative properties. There is scalar multiplication with vector. It creates a new vector of in same direction or in reverse direction with magnitude equal to the magnitude of scalar times of original vector. Our next discussion is Next discussion will be subtraction of vector. This is one of the interesting fact, that is subtraction. Addition we have defined as the vector which gives same effect, same physical effect. If it gives same physical effect, then this is addition, because we know that vector is associated with a direction. Direction of vectors cannot be added. So during addition of vector, we have just assumed that the resultant vector will create same physical effect of vectors being added. That was the definition of addition. Because we know that direction cannot be added, or it cannot be subtracted, or direction cannot be multiplied, direction cannot be divided. Multiplication, addition, division, subtraction, these operations cannot be done with direction. So here the addition was just mean to say that it is the to finding the net effect of these vectors being added. So subtraction of vector. So how we define the subtraction of vector and why it is needed? Because I have already mentioned you, there is a vector A, multiply this vector with minus 1 into A, that is a new vector minus A vector, this is minus A vector. So there is third vector left, vector B. So we can add vector B and A like this. This is A, this is B, and this is A plus B. Now if we add this minus vector, negative vector with this vector, then this is minus A vector. At the head of this vector, I will start tail of this vector B. So the net vector, resultant vector is this. This is B minus A. You can write it like this. So this is the way we define subtraction of vector. Subtraction of vector is nothing but a special kind of addition where we add two vectors in such a way one of the vector is negative vector of original vector. So this is vector A, this is vector B, this is A plus B, A plus B. This is vector B, this is vector minus A. So we have written minus A, then added B, and then resultant vector starting from tail of initial vector and head to last vector is B minus. This is the way we subtract the vectors. So where this subtract, so to directly how to remember this subtraction, I have explained how this subtraction is done. Suppose there is vector A, there is vector B, this is vector A, this is vector B, then how to directly subtract vector A minus B, how to remember it? You can carry out the operation, reverse the vector B, add vector B minus B to vector A and find A minus B. But directly to remember this subtraction, A minus B, you are subtracting vector A minus B. So unlike addition, where we have used sequential technique in triangle law, we have used sequential technique, that is end of one vector, start of second vector, head of first vector, tail of second vector, that is sequential. To add, here we to subtract, you just join tail of these two vectors. This is vector B, this is vector A. There is addition, you can see we have used B, D. Here we have used tail of A and joined it with head of B. and find a b plus a, that is the resultant vector. To find a minus b or b minus a, just join tail of these two vectors. If you are finding a minus b, then the third vector complete the triangle a minus b. The vector which is subtracting here, draw the head of the vector. This is a minus b. This is just to remember actually. Join the tail of vectors being subtracted. This is vector a, this is vector b. To find a minus b, put head of the last vector, which is the subtraction vector, with a. Head of a and head of the subtracted vector will join. This is a minus b. Similarly, to find b minus a, you have to join the tails of both these vectors. This part will be same. Complete the triangle, this part will also be same. Just you are subtracting a from b, so the subtracted vector's head will join with b, head of b. So this is b minus a. This is just for remembering. Join the tail of two vectors which you want to subtract and complete the triangle, and the head of final vector will be located toward the vector which is subtracting other vector. If head is toward vector a, then a is subtracting vector b. B is being subtracted from vector a. So the a minus b head will join with a. If you are finding b minus a, then join the tail of AB, complete the triangle. Here b is subtracting vector a is being subtracted from b. So the head of this final vector will join with b. This is the method of directly finding a minus b or b minus a. A minus b and b minus a both will have same magnitude. You can see both will have same magnitude, but their direction will be opposite. The head of the resultant subtracted vector will be towards the vector which is subtracting other vector. That's the point to remember. Similarly, you can subtract the vector using parallelogram law. Let this is vector b, let this is vector a. Complete the parallelogram. Here you know this was the vector a plus b. There is another diagonal, this. So this diagonal will be equal to a minus b or b minus a. This is vector b, this is vector a. If you are finding a minus b, then the head of this vector will be towards a. If you are finding b minus a, then head will be towards b. So this is vector b minus a. And this is vector a minus b. The magnitude of this vector a minus b will be equal to b minus a is under root a square plus b square minus 2 a b cos theta. This is the angle theta. As you have used earlier method a plus b, there it was plus. Vector a plus b equal to a square plus b square plus 2ab cos theta. Similarly, vector a minus b or b minus a, modulus will be equal to a square plus b square minus 2ab cos theta. Okay. So this is the method to find subtraction of vectors by using parallelogram law. Now we will see both parallelogram and triangle law are same when we use method of subtraction. So let vector A, vector B complete the triangle parallelogram. This is vector A minus B. So by triangle law we have also discussed that just join the tails of both vectors A and B at one place, and the third vector directing its head towards A will be A minus B, or directing its head toward B will be B minus A. Same thing we are getting from parallelogram law. We can use simple trigonometry to find the theta, alpha, whatever it is, for A minus B also. Later on we will discuss another technique to find the resultant vector by dividing components in perpendicular direction, which is very useful. You need not to use this parallelogram and triangle law, which are quite cumbersome formula. You have to just divide all vectors in perpendicular directions. That we will discuss later. How to divide vectors in components. So that will be very useful. You can use this method of dividing vectors in perpendicular components for all types of vector problems. You have to just remember one method for vectors. That's all. These are just for your understanding and basics. You need not to use this actually, because only useful technique of vector is divide all vectors in perpendicular direction, x and y axis, toward x and toward y, and then add them algebraically in x and y direction, and then use Pythagoras theorem to find resultant vector. So let there are two vectors which are perpendicular to each other, A, B. So we know that trigonometric formula for perpendicular vectors for right angle triangle is the most simple formula. That's why we will use this formula everywhere in vectors, because this is the most simple formula. So here A and B. You want to add this vector, transfer this vector here to add it sequentially by triangle law. And you know this is the vector C, which is A plus B. This is 90 degree. This is 90 degree. Here you can see that C square is equal to A square plus B square. You have to just remember this technique to solve all types of vector problems. All types of vector problems you can solve by right angle triangle techniques. Divide those vectors in vertical and horizontal components. Find their resultant vector in vertical and horizontal direction. Single vector in vertical direction, single resultant vector in horizontal direction, and add these two vertical vectors. These will be the two vectors you will find to add finally. So C square, resultant of these two vertical vector is C square is equal to, or you can see resultant is A square plus B square. You need not to use parallelogram formula, because that can also be reduced to a problem of vertically inclined vectors, perpendicular vectors. And here the resultant vector will have angle theta from vector B, and this tan theta is equal to vector A by B. Only this thing you have to remember to calculate all types of vector problems in physics. That's it. Because we use this technique because formula for right angle triangle is most easy. Pythagoras theorem and tan theta can be calculated with simple expressions. That's why we will use it everywhere in physics. Parallelogram law and triangle law are just to understand the concept. So for two perpendicular vectors A and B, resultant vector is under root A square plus B square, that is the magnitude, and direction of resultant vector is given by this expression, a by simple trigonometric definition of tan theta. So for perpendicular vectors, you can see, you can easily find resultant vector magnitude and direction. Now you can see from this expression there are two vectors A and B. If their resultant vector C is written as like this, and C square is equal to A square plus B square, this means vector A and B are perpendicular. You can also see in reverse way, opposite way, as we have earlier discussed, that for perpendicular vector, resultant vector is given by this. You can say if resultant vector is this, then this A and B are perpendicular vector. And second important thing, for perpendicular vector only, for perpendicular vector, if A and B are perpendicular vectors, then mod of A plus B is equal to mod of A minus B is equal to under root A square plus B square. Then you can see here, these are two perpendicular vectors, B, A minus B, this is B minus A. As we have discussed triangle law, this is B minus A, and B minus A is, this is perpendicular vectors, so B minus A, this length will be equal to A square plus B square. Similarly, if we add A plus B, A and join sequentially vector B, and this is A plus B, A plus B. This A plus B is also A square plus B square. So you can say if A and B are perpendicular, then A plus B vector and A minus B vector both will have same magnitude, A square plus B square. Next thing, in subtraction of vectors, as we have discussed, the addition of vector is commutative, it is associative, and it is distributive. But this is not true for subtraction of vectors. You can see vector A, vector B. We have joined tail of these two vectors. So this vector is A minus B. And this vector is A minus B with its in this direction. Similarly, this vector is B minus A. So A minus B is not equal to B minus A. Unlike A plus B is equal to B plus A. So subtraction of vector is not commutative. Now we will see where we use subtraction. As you will say that subtraction is just a special part of addition. Subtraction is not different at all, it is the special part of addition. But sometimes subtraction of vector is used in a manner where only it is defined. Like for example, this is extensively used in the concept of relative velocity. Concept of relative velocity, I will just discuss concept of relative velocity, how the vector subtraction method is used to find the relative velocity. And second application of subtraction of vector is position vector. By position vector you can find the new vector. First I will go, our next important discussion will be component of a vector. Till now we have discussed about addition of vector, subtraction of vector. Now we will discuss reverse process of addition. Addition of vector is finding the resultant vector which have same effect as the vectors being added, will have combined effect. So the resultant vector will have same effect of that combination of individual vectors which are being added. That is the concept of resultant vector. Now we will discuss concept of components of a vector. That is just the reverse process of addition, of finding addition. And this finding components of vector is very useful to solve the physical problem which I have discussed earlier. You can divide the component in x and y direction and add all the forces in x and y direction or any other vector component in x and y direction and easily find the resultant by using Pythagoras theorem, which is very simple. Otherwise, using triangle law and parallelogram law, we will have to go through very rigorous calculations. So what is component of a vector? As I have told you, this is just the reverse process of addition of vector. In addition of vector, we were adding two vectors to find the resultant, single vector. In this, we will break a single vector in two or more than two vectors. That is the concept of components of a vector. So this is the vector. So this is the vector. If we start that this is the resultant vector. Resultant of what? It can be resultant of two vectors. It can be resultant of three vectors. It can be resultant of four vectors. It can be resultant of 1000 vectors, 2000 vectors, infinite number of vectors. So a single vector can be expressed in terms of 2, 3, 4, 5, 1000, 2000 n number of vectors. See how? This vector, there is another vector A. We will just join this vector A and this A, B. So R is equal to A plus B. Again have another vector till here and join it. So this vector is C and this vector is D. So R is equal to C plus D. Again increase it here. This vector is E and this vector is F. So R is equal to E plus F. So from this example you can see a given vector can be divided in infinite number of combinations of two vectors. You can have infinite number of such combinations for which the resultant vector will be R. R is resultant of A plus B, R is resultant of C plus D, R is resultant of E plus F. Again you can see G, this vector is G and this vector is H. So R is resultant of G plus H. So you can find infinite number of combinations of two vectors for a given vector whose addition will be equal to this vector. Resultant will be equal to this vector. So a single given vector can be represented as infinite number of combinations for a given two vectors. Now we will see another example. Here we have divided a single vector in combinations of two vectors and we saw that we can have infinite number of such combinations of two vectors for which given vector will be equal to resultant vector. Now we say a given vector is R. From polygon law, say this vector A, this vector B and this vector C. We have arbitrarily chosen these three vectors in this direction, and in such a way this whole loop is formed as a polygon. The loop makes a polygon. So we can say by polygon law R is equal to A plus B plus C. Similarly, another polygon you can make up to here, up to here, and up to here. This vector is C, this vector is D, this vector is E. So R is equal to C plus D plus E. So from polygon law, you can say there are infinite number of combinations of three vectors. Similarly, you can have infinite number of combination of 4 vectors, 5 vectors combination, 6 vector combination, 10 vector combination. There are infinite number of 10 vectors combinations. There are infinite number of any number of vectors combination whose resultant will be equal to R. So this is the reverse process of addition, and from simple geometry you can easily see that a given vector can be represented as a resultant vector of infinite number of combinations of 2 vectors combination, 3 vector combination, 4 vector combination, 5, 10, 1000, 1 lakh vector, 2 lakh vector. By triangle law and by polygon law, you can see a single vector can be divided into infinite number of vectors as a resultant vector of those components. So these all vectors which we have discussed, combinations, they are called component of this resultant vector. Any two vector A, B, we again draw this A vector, B vector, and this is the resultant vector. These A and B vectors are called component of R. By the definition of component, it is part of R. These two vectors makes vector resultant vector R. So these two vectors are called components of this vector. So any vector R can be represented in terms of its addition of its component, and the combination of this component is infinite. Components of vector we have seen by polygon law and by triangle law, that a given vector can be divided in infinite number of components based on polygon law, and there are infinite number of combinations of components of a given vector for whom their resultant will be equal to given vector. So now we will take a special case of components of vector which is frequently used in solving the problems, where we divide a given vector in perpendicular components, two components which are perpendicular to each other. So for example, this is a vector A, it's a vector AB. So by triangle law, we know there are infinite number of combinations of different vectors whose resultant will be equal to this vector. Similarly, when we divide this given vector in perpendicular components, so let us say one direction is this, one given direction is this, so second perpendicular direction will be this. So for this combination of given perpendicular directions, there will be fixed components of this given vector, fixed perpendicular components. So you just draw a perpendicular from this point on this line, let this is O, this is A. So vector OB is equal to vector OA plus vector AB, and let this angle is theta. So for a given vector in a direction theta and perpendicular to this given direction, there will be only one combination of vectors of combination of components whose resultant will be equal to this given vector. So we from this we see tan theta is equal to mod of vector AB divided by mod of vector OA. So in this direction, or we can say OA, vector OA is equal to mod of vector OA is equal to mod of vector OB cos theta, and mod of another component AB is equal to original vector mod of original vector into sin theta. So this is very important formula to find the components in perpendicular direction at a given direction theta from given vector. Similarly, you can see, we want to find perpendicular components in this direction, and their perpendicular is this. So this angle is alpha. So in this direction, similar to this argument, in this direction, one component will be OB cos alpha in this direction, and perpendicular to this in this direction, another component will be OB sin alpha. Similarly, we can again find another direction with angle beta, and perpendicular to that next component in perpendicular direction. So in short, we can summarize this perpendicular component method for a given vector AB. There are infinite number of combinations of perpendicular components, because suppose we can take perpendicular component like this, in this direction angle theta 1, similarly angle theta 2, these are also perpendicular. Similarly, you can have infinite number of combinations of perpendicular directions for which this vector can be divided. This is theta 2, this is theta 3. So there will be infinite number of perpendicular axes, where the component of AB can be divided. So for a axis, for a particular axis, like there is vector A, B, and we want to divide this given vector in perpendicular components. When we fix this angle theta, then these infinite number of combinations becomes specific combination. There will be only one particular combination for a given value of theta from given vector. So when we fix the theta, let this is theta. When we fix the value of theta, then perpendicular to this axis, this angle is also fixed. This is 90 minus theta. So the component in this direction, AX, let this is AY. Component in AX direction of vector AB will be mod of AB cos theta so let this just draw a perpendicular from point B on this axis, and let this point is H and draw another perpendicular from this point is K. So component in AH direction, vector AH will be AB sin theta, AB cos theta. Mod of this vector will be equal to mod of AB into cos theta, and mod of another vector perpendicular this direction, that is AY, AK, we will see AK will be mod of AB sin theta. So when we fix the angle theta, then the perpendicular components of the given vector is fixed. There will be only one combination of perpendicular components for a given vector and a given direction from vector, and this direction theta, tan theta will be equal to vector AK divided by vector AH. Mod of vector AK, that is perpendicular, one of the perpendicular component, and divided by mod of vector AH, that is second perpendicular component. So the direction, in direction theta from given vector, the perpendicular vectors which are component of original vector are fixed, that is unique. There will be only one combination of these perpendicular vectors for a given vector when the angle theta is defined, when the angle theta is given. Otherwise, for different angles, theta 1, theta 2, theta 3, there will be infinite number of combinations of perpendicular vectors. Infinite number of combinations whose resultant will be this. So this method we use frequently in real problems, solving for physics. During solving the problems, you will see this method frequently, where we divide all the vectors, more than one vectors, in two given perpendicular vectors, two common reference. We select two common reference of perpendicular vectors based on east, west, north, south, or any other reference direction, and in that direction we find components, perpendicular components of all vectors. So in that way we can easily add components in single direction and other components in perpendicular direction. That is very easy method to find resultant vector of more than one vectors by dividing them in perpendicular components. We will just discuss some application of these methods. This method is extensively used in statics branch of physics and maths, statics, where the equilibrium of a body, equilibrium of an object is statistical. Let this is an object. There are forces. This is X and this is Y. This is one force F1. This is another force at theta F2. This is F3. This is at alpha F4. So these are the forces F1, F2, F3 are acting on this particle. They have different angles. So if you will find it, the resultant of this force from polygon law, so you will have to calculate different angles and direction and the very complicated formula. Sometimes there may not be any formula available in polygon law. And if you find the triangle law, then you have to first add F1 and F2, then find the resultant, then add a resultant with F3, then find the resultant, then add resultant with F4, then find the resultant. Very lengthy process. So here, what we will do, we will find components in X and Y direction for every force. Let Fx in x direction is equal to F1, this force is in x direction, plus F2, you will find components of F2 in x and y direction. In x direction it is F2 cos theta, as I have discussed earlier, dividing a vector in two perpendicular components. F2 x-axis component will be F2 cos theta and y-axis component will be F2 sin theta. Plus third vector, it has zero component in x direction, so it will not be considered. For F4, F4 will have vector in negative direction. Let us, for convention, just we can use any side positive and any side negative. So for as per convention, we use positive side of x as positive and negative side of x as negative. Similarly, positive upper side of y is positive and lower side of y is negative. This is a convention. So component of F4 will be like this. So x component will be in negative direction. This angle is alpha. So this angle with x axis is alpha. So F4 x component will be F minus F4 cos. So this is the x component of all forces. Similarly, and this will come to F1 plus F2 cos theta minus F4 cos F2. Similarly, in y direction, Fy, Fx, y component is will be 0. F2, y component of F2 is F2 sin theta plus F3, this vector is in y direction, so whole vector is in y direction. Similarly, F4, this is in negative direction, by convention this is negative, plus minus F4 sin L. Plus and minus we are using because these are vectors. These are vectors. Vectors, negative vector and positive vector. So these two vectors are positive in one direction, and when will we add vector in this direction, we can simply algebraically reduce those vectors. For collinear vectors, we can use algebraic summation. That's why these problems are simplified, because we find collinear vectors in x direction. Positive direction, these vectors. Negative direction, this. As these vectors are exactly opposite, they can algebraically added. We need not to use geometry for two vectors which are collinear. So this will be F2 sin theta plus F3 minus F4 sin F4. So magnitude of F1, F2, F3, F4 are given and these angles are given. We can find Fx and Fy by algebraic addition. Here geometrically we need not to represent vectors triangle law, because two vectors are in same line. Then we can algebraically add them or algebraically subtract them to find net vector in that direction. What we have done here, we can find Fx and Fy. Now from this we can calculate Fx and Fy. So resultant force will be under root Fx square plus Fy square. Very simple formula. Fx and Fy have been calculated from given forces F1, F2, F3, theta and alpha. F net force will be Fx, modulus will be under root Fx plus square plus Fy square, and tan theta will be Fy by Fx. So you can find the direction of resultant vector. So we will just, so this is very important and potential method to solve all vectors problem. Similarly for statistics, if that object is in equilibrium, in that case Fx, Fy, you can say Fx is equal to 0 and Fy is equal to 0. both perpendicular vectors will be zero if body is in equilibrium. That is the condition of equilibrium. We write fx as sigma fx is equal to 0, sigma fy equal to sigma fx is x component of all forces in x direction, addition of x component of all forces in x direction, addition of all components in y direction. Both components, see, for perpendicular component, if the resultant vector, this is very typical observation of particular vectors. For a particular vector, the resultant is 0, this implies A, B. Suppose two vectors are there. If the resultant is 0, then A barabar B is equal to 0. Both these vectors have to be 0. Because perpendicular vector R is equal to A square plus B square. Modulus of R is equal to A square plus B square. This resultant will only be 0 when A and B both are 0. Similarly, this is typical observation in perpendicular vectors. So when we divide all forces in x and y direction and we say that body is in equilibrium, that means resultant force is 0. Resultant force is 0. That is only possible when both x and y components, x and y perpendicular components of forces will be 0. This is the condition of equilibrium which we use in statics, extensively used in statics. Similarly, to find net resultant force in x direction, if it is not in equilibrium, we can find forces in x and y direction, then net force, and based on direction of net force, we can find the net movement of particle along the resultant force. So you have to just remember only this method of finding components in x and y direction, and then for addition or finding component in x and y direction, and similarly resolving force in x and y direction.